Hi there. This lesson is about weather systems and storms. Your vocab for this lesson. The first one is tropical. This is an air mass that is warm. So it's usually a portion of air that is heated up like over the equator. That's one of the warmer areas on our globe, and so that's where it's warming up. Polar is an air mass that is cold. So obviously go to the North Pole, that's cold air, it begins to sink. And so sometimes when you hear about weather masses, you'll hear meteorologists say that there's a polar front or there's a tropical storm coming through, which means cold and warm. Marine is a moist air mass. So this is when we have the warm and we have the cold, we also have moist and dry. So air masses that are moist typically form over oceans, and so the marine air mass is something that forms over an ocean, so it has a lot of moisture in it. Continental is a dry air mass. Continental makes me think of continent. The United States is a continent, North America is a continent, and so it forms over a piece of land mass, which means that it's really dry. So marine is moist and continental is dry. So a meteorologist can say a tropical continental air mass, which is a warm, dry air mass. We also have front. This is where air masses meet. So you'll have a cold air front, you have a cold air mass and a warm air mass, and where those two meet is called a front. A cyclone is a swirling center of low pressure. So sometimes these winds come together and they clash and they start to spin when they go around each other, and then it creates this low piece of air pressure in the middle, and this is when we start to see our hurricanes and tornadoes, when we have this cyclone effect in the air masses. Very important concept number one is all about fronts when those air masses are meeting. There are four types of fronts. The first one is a cold front. So I've got my little grass here, and I've got good old Miss Staten standing on the grass. I've drawn a cold air mass, and I've labeled it cold air, and the cold air is moving this way. When the cold air mass comes, it pushes the warm air mass up and kind of over it, and it creates all of this moisture right at the base of it. So you get this really funny looking cloud that's really tall and dense. And because it's all tall and dense, it typically forms some cumulonimbus clouds or some cumulus clouds because it's pushing all that weather together. So a cold front is fast moving cold air that takes over warm air. And the symbol for that is a line. And then you have these blue triangles, kind of looks like shark's teeth, to symbolize that the cold air is pushing through the warm air. The next front is a warm front. So you've got a warm front that is moving fast, and that's the line that I've drawn right here, and you've got cold air that's underneath it. The cold air is pushed this way while the warm air kind of slides on top of it and continues to squish it out of the way. When this happens, there's clouds that form, but they're more stretched out and more vertical because they're the ones that are sliding the cold air out of the way. A warm front is warm air mass that takes over a slow-moving cold air mass. And in weather forecasts, we have one line, and then we've got little circles colored in to represent the warm air that's pushing the cold air out of the way. The next front that we have is a stationary front. Here's the ground and Miss Staten standing right there. You have a cold air front, which is one line right here that's moving this way. And then you've got a warm air front that's trying to push in the other direction. This creates clouds in that V, and it squishes all the moisture down, and so then you get rain coming down in between these two fronts. So a stationary front is cold and warm air meet, but neither can move each other. So this happens actually in North Carolina because we've got the tropical marine front coming through, or that warm, moist water coming in from the ocean. And then we've got the cold, polar continental air mass moving in from the mountains that's dry and cold. And they come in and they meet, and then they get into a stationary front. The last one we have is an occluded front. That is, so here's our ground. Oh, I didn't draw my statement on this one. I must have been getting out of the way. Here's the cold air front, and then there's another cold air front because the two were coming on top of each other, and then it squishes a warm air front up on top of it. So it's like there's a cold air, warm air, cold air, and the cold air squish it up top. So here's a cold air, and then there's warm air coming up top. So an occluded front is when warm air is caught between two cold air masses. This creates clouds up above, and then there's some rain that is in the first cold air front. The symbol for this is a combination of cold air and warm air dots, but they're all on the same side, saying that they're all in the same direction. I forgot to say the symbol for the stationary front. It's got the cold air on one side and then the warm air on the other side, saying that the two are smacked together and they're fighting against each other. Very important concept number 2 is storm systems. So all these different air masses come together and they create different types of storm conditions. We're all very familiar with rain, but there are different types of storms that are up above that create that rain. So the first one is a thunderstorm, which we're all pretty familiar with. Some of us freak out about it. Some of us go, ooh, that's pretty cool. So a thunderstorm, here's the ground. I drew a cumulonimbus cloud. Then I drew arrows symbolizing that there's cold air that is sinking. So the cold air is going down, and then there is warm air that comes up and goes up into the atmosphere, which is these lines that come up. Then I drew a thunderbolt, because when you have cold air and warm air moving past each other like this, it creates a lot of friction, which then charges the electrons that are in the cloud. So that's why you see positive and negative symbols within the cloud, because those air masses are charging all the electrons in the cloud. And eventually there's so much charge that it creates a spark, which is the thunderbolt that comes down to the ground. So I've labeled the cold air, I've labeled the warm air, and then this says positive and negative charges build up and create massive sparks, which is the thunder. Oh, and lightning. The next storm system that we have is a tornado. So a tornado is like a cyclone, that you've got spinning air and you've got low pressure in the middle. So it starts with warm, moist air rises into a cumulonimbus cloud. So you've got warm air down below, and it begins to rise up into a huge cumulonimbus cloud. So cumulonimbus is that rain cloud. The warm air spins when it hits other winds. So the warm air is rising, and then a cold air mass might come through and spin that warm air in a different direction. So when the air starts spinning around and around, it begins to suck the cloud down to the ground. So the warm air is coming up, it's getting spun, and when it's spinning all the way up into the cumulonimbus cloud, it brings down the cloud so it looks like the cloud is coming all the way down to the surface of the ground. That is a tornado. The next system that we have is a hurricane. Here's our hurricane here. So hurricanes are very similar to tornadoes in that it's a swirling air mass. It's got warm, moist air, and it's particularly warm and moist because it's forming over the ocean and near the equator. I think hurricanes basically originate in Africa. They start on that side of the Atlantic Ocean They come across the Atlantic and build moisture and build speed until they get into that big funnel shape, bringing the ocean and bringing all the moisture with them. And then they hit the northeast side of the Americas, or North Carolina, or Florida, or Cuba, or all of those islands there. And then all the moisture and the heat dies away because it's hitting the land. So we've got our cyclone formation. The warm and moist air is getting pulled up and turned around. Air comes out the top of this cyclone formation, and once it's up there, it starts to cool. So we've got warm air and cold air cooling. The cold air that's up there begins to sink down through the center. So cold air sinks down through the middle, making the eye of the hurricane. Everybody talks about the eye of the storm. That's cold air that is sinking down through the middle, that's very calm, there's no rain, and then all the weather pulls up again around it. So we've got ocean, we've got swirling, we've got an arrow representing the warm air, we've got rain, we've got cold air on the top, and we've got cold air sinking as it cools. That is a hurricane. The last storm system that we will typically see is a snowstorm, which happens to be my favorite. So here's the land, and here is my house, and here's Miss Dayton stuck in her house because there's been so much snow that it's blocked me into my house. That's a typical snowstorm in the Northwest. So here's all of the snow that has locked me in my house, and then I've drawn a tree with ice hanging off the tree. And this is something that we talked about with North Carolina winters and North Carolina snowstorms, is that it will rain on top of the trees and then it will freeze, which then will weigh down the tree branches and then make them break and block off the roads, and it will freeze over the bridges and make it really dangerous to drive in winter snowstorms. So, snowstorm, there are freezing temperatures which can produce snow or ice, which then make hazardous conditions for traveling. Very important concept number 3 is how we predict weather, or predicting weather. There are 3 main ways to predict weather, and then there's ways how we observe the weather. So the first one is weather balloons. We'll send a weather balloon up into the upper troposphere, or sometimes the lower stratosphere. And in this balloon are all of these measurement tools that record the different types of attributes that you want to know about weather. So it is used in the upper troposphere to record the temperature, air pressure, and humidity of the air masses that are above a certain city. The next one is an automated weather station. So all across our country, they've got designated weather stations that record information that then can help meteorologists build pictures of what's happening across the country. So automated weather stations, I've got my land and my grass. I built a small house. I've got a thermometer here to say that they measure the temperature. I've got the wind gauge that spins to see how quickly the wind is blowing, and then I also have a wind sock to tell me which direction it's blowing. There are over 1,700 or 1,700 stations reporting weather from different locations. So you've got one in Durham, you've got one in California, you've got one in all over the country giving you a picture. Can you guys hear the lawn out there? They're mowing the lawn and it's really noisy. Anyway, we got one more thing. I'm not quitting the video. The last thing is weather maps. So this is something meteorologists use to show pictures of the weather that's happening. So I've drawn a really funky picture of the United States. And then there are 4 different types of things that are shown on these maps. There are fronts, and you can see the lines of the fronts that I talked to you about earlier. There are high and low pressure. So over Oregon and Montana, I've drawn high pressure, and this is something that we saw when we looked at convection currents and we labeled the convection currents. That's what we see there. They'll label precipitation. So like in Florida right now, I've drawn that there's a lot of rain, and so you'll see precipitation patches all over the country. And the last one is the temperatures. With the temperatures, you'll see, okay, well, there's a high of 58 in Montana, or there's a high of 84 in Arizona. So these are the typical things that you will see on a weather map.